So inverse of the hyperbolic cosecant function, cosecant hyperbolic inverse. So this is defined on all real numbers except 0. So you need to take out 0. Its image is all real numbers except 0. Here are the steps to identify the inverse of cosecant hyperbolic x. Set y equals cosecant hyperbolic x, which is 2 by e raised to x minus e raised to negative x. Interchange x and y and then solve for y. X is 2 over e raised to y minus e raised to negative y. Cross multiplying, I get 2 equals x e raised to y minus e raised to negative y. This is nothing but 1 by e raised to y. So multiply throughout by e raised to y. 2 e raised to y equals x e raised to 2y minus 1. Get everybody on one side. X e raised to 2y minus 2 e raised to y minus x is 0. So e raised to y is your unknown. So use quadratic formula. Negative minus minus 2 plus minus square root negative 2 square minus 4ac. You see? So that gets me plus 2 plus minus square root 4 plus 4x squared the whole over 2x. So you get the 4 out. That gets to become a 2. That 2, this 2 and this 2, they cancel, you see. So I'm left with 1 plus minus square root 1 plus x squared the whole over x. Now notice, we want e raised to y. So we want this to be a positive. Therefore, I need this denominator to be positive. Okay. So it is a bit, there is a little bit of care to be taken, but overall, I will say, take the positive option and divide by absolute value x. Okay, so that ensures e raised to y is positive. Once you have that, y is natural log of all this. Okay, so in the numerator, one has to be a bit careful because you see 1 plus x squared is always greater than 1. So that square root will be greater than 1. So we don't want the negative there. If we really have to be careful here. So leave that, choose the positive option and make sure this is positive by taking absolute value. So we have identified cosine hyperbolic inverse to be natural log of this expression with absolute value x in the bottom, which is same as natural log of the numerator minus natural log of the absolute value x, and all of this is defined for every x that's non-zero. Okay, when x is non-zero, all of this is defined. In particular, this is defined when x is non-zero. So once you have all of that, you want to take the derivative of this minus derivative of this. So derivative of the first chain rule minus derivative of the second. I have maintained absolute value to make sure we are in the correct domain basically. Okay. When you simplify all of this, go through this carefully, careful simplification, you should get negative 1 by absolute value x square root of x squared plus 1. So derivative of cosecant hyperbolic inverse of x is negative 1 over absolute value x square root 1 plus x squared. So notice x squared plus 1 is same as 1 plus x squared. It's just rewritten a certain way because of the tradition or something. Now, inverse of the hyperbolic secant function. So secant hyperbolic inverse is from open 0, closed 1 until close 0 to infinity. Here are the steps. Y equals secant hyperbolic x, that is 2 by e raised to x plus e raised to negative x. Interchange x and y and then solve for y. So x is 2 by e raised to y plus e raised to negative y. Cross multiply, 2 equals x times all of this. E raised to negative y is 1 by e raised to y. Clear the denominator, 2 e raised to y equals x, e raised to 2y plus 1. Get everybody on one side, keep that the positive side. Okay, so you just move this to the other side. Now use quadratic formula. Notice e raised to y is the unknown. Using your quadratic formula, you get this situation. Now, I want again e raised to y to be positive. Also remember my x is positive, so I don't need to take absolute value. I also know x is less equals 1, so that's safe here. Okay, so all I choose is the positive option. Because this would be less than 1, I don't want to choose the negative option. Overall, it would become negative if I choose the negative option. So choose the positive option, take natural log of both sides, and you got your secant hyperbolic inverse to be all of this, which is difference of natural logs. Remember, x is greater than 0, so I don't need to take absolute value there. At this point, take derivative. Derivative is nothing but derivative of the difference, so one at a time. You go through this entire calculation, you're left with negative 1 over x times root 1 minus x squared. So that is the derivative of secant hyperbolic inverse of x. Lastly, inverse of the hyperbolic cotangent function. Cotangent hyperbolic inverse is, you see, away from negative 1 to 1. So you have interval negative infinity to negative 1 open, union 1 to infinity open. You land into all real numbers except 0. To find, to identify the inverse of cotan hyperbolic, set y equals cotan hyperbolic x, interchange xy, solve for y. You go through this procedure, cross multiply, clear the denominators, get the e raised to 2y terms together, and eventually divide by the coefficient here, coefficient. So that minus, if I flip these two, becomes, you see, the minus is gone. So y is half natural log x plus 1 by x minus 1. This is nothing but difference of natural logs. All right. So this is valid when x is less than negative 1. No, this is valid. Okay, when x is less than negative 1, then the quotient is valid. This is not valid there, but this is valid. So this is simply an arrangement. Mind you, this is valid for x less than negative 1 as well as greater than 1. Okay. When you take the derivative, you split your natural log and you proceed until you get 1 by 1 minus x squared. So derivative of cotan hyperbolic inverse is 1 over 1 minus x squared. So here is a summary of everything we have done so far. Hyperbolic functions, their domains, inverse hyperbolic functions and their domains. Hyperbolic functions, their derivatives, inverse hyperbolic functions and their derivatives. Okay, so that completes the theory of this particular section. Okay, have a good look. Maybe you will be able to write these things yourself, and we'll continue on problems from web work in our next video. Okay, until then,